Hi everyone, do you have any doubts regarding yesterday's or previous classes? Okay. Am I audible?
Yeah, audible.
Yeah. Okay. Today we will go over how to. Until now we have just written data directly in our code, right? Like if I wanted to write a name, I had to do this. Hmm. Until now, if I wanted to represent some form of data, I would have to manually write it like this. If the name is John, something like this. And if I wanted to write a numeric data type integer or float, I would have to write like this directly into the code. But what about when we want to accept the data from the user? When we, this notebook is all about that. Python by default provides us with an function called input. This function will take a string as an argument. Like I said, right? Functions take something as an argument. This input function will take a string as an argument, and this string is nothing but what you want to display to the user while accepting the data. Let's say if you are designing a login screen for a website, and the website we will ask, right, what is your name? We provide an input box, and on above the box we will write, please enter your name in here. Similar to that, when input will accept data from the user, and the message that should be displayed to the user should be passed as an argument to the input input function. Please enter your name. And since I want to store this data, let's say username. I am capturing the value returned by the input into an. Take a close look at what happens when I try to execute this line. See, this is asking me for please wait a minute. Please enter your name. It is asking me the message that is being displayed is nothing but the argument, the string we pass to the input function. Now here I am writing a list. And now let's see what data is present in the variable username. See, input function is nothing but it will allow us to accept input from the user. Input function takes an argument, which is nothing but a string. This message will be displayed while accepting the data. And the returned value is the user input data, which can be directly captured into a variable and can be reused again. But there is a drawback to input function. What if you wanted to enter your age? See, age is an integer or a float, right? Please, no, let's make it please enter your salary. Now, at the same time, I'm printing the age again. So we can see, take a look at it. This is asking me to enter my salary. Let me write 300.5 something. Uh, See, this is accepting the age, and printing the age. However, if I try to check the type, as we know, there are different data types, right? Integers, floats, strings, and booleans. I am trying to check the data type of the value that I have entered. See, this is showing up as a string. But if you remember, you entered a number, but it is showing as a string. This is because whatever the value you enter into the input, it will always be written as a string. So even when you enter an integer or a float, it will become a string. Then you might ask, this is useless, right? What we should do when we want an integer, or when we want to capture an integer. And there is a simple way to do this. All you have to do is yesterday at the end of the data types class, I just told you that if you want, you can cast one data type into another as long as it is correct. Here, if you entered a number, that a correct number without any alphabets and something like that, you can directly cast it into an integer or a float. Okay, let me try casting it to a float. A is equal to float age. Nothing but I am casting the value in the age and storing it in the age again. And I am trying to print the value as well as printing the type of the value. See, here after casting, I printed the value. So this looks identical, but when you take a look at the type, it became float, right? What if we entered a wrong value? See, in this cell, int age 58. Here, I am asking user to enter his age, then immediately printing the age value and trying to print the type of the user entered value, and then casting the value into a float, then printing the value and also printing the type of the value. Here, let me say, please enter your salary, right? Let me say 2 lakhs. If you know input is taking this 2 lakhs as a string, which is correct, and it is printing the age as age value 2 lakhs, and the type is also a string. But what we did here was we tried to cast 2 lakhs, which is a string, into a float, but it does not agree, right? That is why this is failing. So if you wanted to capture integers or floats or even booleans using input, the input should be strictly castable into the target data type. Else, when you try to cast it, it will fail. By default, input will always return a string. Clear? Did anyone did not understand the input function? Good.
Yeah, clear, sir.
Do you have any doubts? Did you understand this or not? Okay. I am proceeding to the
Whenever we use that input function, it will ask us to enter a value, no?
yes.
Okay.
Whenever whenever the line runs, the input function runs, it will ask us a value. It will show the argument that we written inside the function as the text to the user, and user entered value will be returned, which can be captured into a variable and reused again. The only caveat is input will always return a string. So even if you enter a number, you should cast it into an integer or a float and then use it. Else it will always be a string. Let me make something easier to understand. Math is equal to
Is that because we are mentioning that input function in double quotes or like what?
yeah, here double quotes, right? Double or single quotes.
Mm.
Is this what you're asking? As I said, input function takes a string as an argument. And in yesterday's class, I told that anything written inside a double or a single quotes is a string, right? Here,
Yeah.
you can even do this. You can either use a double quotes or a single quotes. It doesn't matter. In Python, double and single mean the same. Uh, Please enter your math marks. Print math. No. Let me ask physics. Input. Please enter your physics marks. Here, you just wrote down a snippet that asks the student about his math and physics marks and returns the total. What will you do is, you will just assume both are numbers and math plus physics. Let me write this down. 33. See, I first entered the math marks, that line executed, and math contained the entered value, and now the physics line is executed, and that input function is displaying this message. Now I am entering physics marks as 34 by physics unresolved E.
Physics spelling
Yeah,
in the input function.
yeah, fine. P A. Running the cell again, 33, 44. See, here you must have expected 77, but it is giving me 33, 44. Weird, right? So what you should have done is, you should have wrapped int or float around them. Triple two, triple three. See, this is the correct way to use it. Just remember that when you are using input, it will always return strings. If you want to add integers or floats, uh, cache them and then use them.
Yeah.
And next, input function, as the name suggests, it will accept input from the user, but there should be something to display the results to the user, right? We generally call them output functions. But if you have been following my classes, I have been using this without even explaining what it is. The print function is the actual output function in the Python. Anything you write in the print will be printed out. We have been using this extensively in our classes. See, even here, what I did was I printed int math plus int physics. This executed first, and then the result was printed, right? Print will accept anything. It will accept any data type, any variable, anything, and it will print it out. And the print function does not have any limit on the number of arguments it takes. You can even write a million arguments in here. 1, 2, 3, 4, 5. You can even write lists in here. You can even write tuples in here. And it will not discriminate. It will print them all. This is a quick way to know the whenever we want to know something, know about the data, we just print it. If we want to know the type or type of data type of the data we are dealing with, what we do is generally we first find the type using type function and then print the return value like this. I have even used it above in here. Where is, yeah. Yeah, here, see, I use it print to print the actual value of the age, and also to know its type, I first wrapped age around the type and then printed the resulted type. And the result will look something like this. It first prints the first argument and then the second argument is printed like this. Good. This notebook is complete. After the class, please go through it. I have explained everything in detail, but the crux is input is used to accept data from the user. It will always be a string, and print is used to display the output to the user. It can be used to print any variable, any data type, any data structure, and it can take any number of arguments. Good. Up until now, we have only seen how we can create data types and data structures, how to store them in a variable, how to accept input from the user using input, and how to print the actual value using print, and how to print the know the type using type method, and then printing it, right? But we haven't uh, interacted data with another data. Like what if there are two strings? I wanted to make something. I want to perform an action between these two strings. What if I have two integers, or what if I have an integer and a boolean? What operations or what actions can I do between this data? Expression in a Python is to put it simply, a single line. Any line in a Python is called an expression. Expression contains data, data types, data structure, or a variable holding the data, and some symbols to represent the action. Something like here, 22 star. See here, by default, you will understand that I am here multiplying 333 with 22, right? I am multiplying 33 with 22. Here, 33 and 22 become the data, right? Data. In our case, this is data, and this is also integer data type in particularly. And star represents the operation. So what we call is an expression is a consists of data and operate, data and symbols. Data is called the operand, and the symbol is called the operator. Operators, the symbols represent which operation is being performed. The expressions can include numbers, strings, variables, and operators. Numbers, strings, and variables become the data, and operators become the action that is being performed between the data. Operators are symbols like plus, minus, star, and slash. There are multiple other operators, but just to help you understand, plus, minus, star, division are the basic operators. Operands are nothing but operand is nothing but a name given to the data upon which we are operating on. Express Expressions can be simple like adding two numbers, or complex involving multiple calculations. Here we just multiply two numbers, right? What if I want to multiply these two numbers, then divide it by 33 by 22. See, even this is an expression. Here I am multiplying these two values, then dividing it by the result of this value, and I can even add something like this. You need not calculate the result, but I'm just showing that an expression can be large. Now let's say I am capturing this in a variable called result. Let me try to print the result too. See, an expression can be simple, just an action between two values, or it can be chained, or an expression can include multiple sub-expressions and so on. The expressions can be nested. One expression can be used inside another expression. If you see this, the whole thing is a single expression, and it contains multiple smaller expressions. Oh, this is one, this is two, and this will become one, and this will become the third one, something like that. Here is an example of the most basic form of expression we can write in Python. X is equal to 5, meaning X is stored in 5 is stored in X, Y is equal to 3. And the result is nothing but X plus Y. Here, I am trying to add X with Y and storing the result in a new variable called result. Expressions in Python. If you see, I have been only using plus, multiplication, division, and minus because we intuitively understand the mathematical expressions or arithmetic expressions since we have been taught to do math from an early age, right? But in computers, if a computer can only do arithmetic expression, only do calculations, then it is useless, right? A calculator can do just can steal the computer's work. A calculator can only do numerical operations, but a computer we even have to make decisions based on data, right? This is the reason why arithmetic expression means math formulas. We can operate, we can represent any mathematical formula or any math operation in Python using plus, minus, star, division, multiplication, power, and so on. Then the relational operators are nothing but comparing. We compare whether 2 is less than 3 or 4 is less than 5. And you might ask, why should a programming language need relational operator? Because this is used to compare data, right? Let's say we wanted to accept only users under the age of 18 into our college. In such case, if we only have plus, minus, multiplication and division, we cannot compare the two numbers that we get. So we inevitably need greater than, less than, greater than or less than or equal to, greater than, equal to or double equal to. These are the relational operators, and the and the expressions that are formed using the relational operators are called relational expressions. Relational expressions look something like this: 33 greater than 33 greater than 55. This is false, right? So when I try to run it, it will return false. See, relational expressions always use data and relational operators. Arithmetic expressions always use integers or floats and return back an integer or a float. Relational expressions take integer, float, or it can even take strings too. Like I can even compare whether 44 is equal to 44. Here, double equal to is also an relational operator. See, relational can take any data type as an input, but will only return a Boolean value as an output. Arithmetic can only take integers and floats as an input and can only return integer or a float as an output. And then bitwise logical expressions. Okay. Logical expression, the easiest way to explain logical expression is if age is greater than 18 and not enrolled in any school, enroll him. If I say, if in this statement, you can make out two expressions or two relational expressions. Age is greater than 18 and not enrolled in any other school, right? And if you see, I placed an end in between. I mean, when this expression is true and the next expression is also true, only allow him. Here, basically the end is called the logical operator, and the expressions we write using these are called logical expressions. Let's say age is equal to 18 enrolled is equal to false. Age is, I just want to check whether age is greater than 18 and enrolled is equal to false. This is a relational expression and this is a relational expression, but the whole is a logical expression. or conditional expression. To put it simply, is age greater 118 equal to age greater than is enrolled. Mhm. There is absolutely no difference between the result returned by the expression inside this print and the expression inside this print. I just return this to make you understand that conditional expressions will always take booleans as an input and will always return boolean as an output. See here, the result of this relational expression is an boolean. This relation expression is also a boolean. And here I am writing an another expression between two booleans using an AND operator. We will go in detail what expressions can contain what operators too. And you can ignore the bitwise expressions. We will never use them. And finally, membership expression. We will also explore this detailed in later section. Just know that if I want to find whether an element is in another element, like let's say I want to find where if A is in John, I could write something like this. Here, A and John are the data or the operands, and in is called the relational expression. This will also return whether a true or false, only return Boolean. See, it returned false because A doesn't exist in John, right? And I can even use this with a list. Mm, wow. Oh, one, two, two. This should return a true because triple two exists in the list. We will also explore this in detail in the later section. Just remember that arithmetic operations are used to derive numbers and make use of numbers only. Relational operators are used to compare any two different types of data and always return a boolean. Logical expressions will always take in booleans and will only output a boolean. Relational, conditional are used to make decisions, and arithmetic are mostly used to calculate the numbers that are before a decision. And membership or expressions are generally used to check whether an element exists in another element or not. Logical operation, assignment, yeah. You might sometimes see the word assignment operator, which is nothing but assigning a data or data type to a variable. That's it. Here, this is an assignment operation. Here, and equal to is called the assignment operator. Is used to put data into a variable. That's it. Arithmetic operations. Now you know that arithmetic operations work with a numerical data types. You want to know how many types of how many and what type of operation that Python support, right? Here is the list. Python supports addition, subtraction, multiplication, division, modulo operator. When a modulo is nothing but like rather than dividing something, let me say I am dividing 300 triple three by 1000. This should be something like 3.33, right? But what if I don't want to divide all the way and just want to know the remainder? See, this will only return the remainder, which is 33. If you still remember how we do divisions using hand, then you might it is easier to understand. Modulo is a percentage symbol is nothing but it will return the remainder after division. Yeah, modulo floor division. Floor division returns the quotient. 3. Floor division is represented by 2 slashes. This is the actual division. This is the floor division. If you see, it will only return the quotient before going into decimals. And modulo will only return the remainder before going into decimal division. And rest are self-explanatory. Plus, minus, multiplication. Multiplication, if you see, it should be x, right? But in programming languages, it is represented by star. Division is slash. This is familiar. Explain modulo or returns the remainder. It might be hard to digest in first, but you will get used to it. Floor division return the quotient. Exponentiation. Yes. Even this is also easy. What if I want to find a square of a number, or if I want to find, if let's say I wanted to find the square of 25. Python allows us to do it using double star. Whenever I do a double star, what this means is there is 25 to the power of 2. Here you can write any number. We will mostly be using the squares or cubes. If we wanted to find a cube, we would have written 3. Remember, it is represented by double star. That's it. These are the only arithmetic operations in Python. You can't find any other operation than this. Yes, arithmetic will only take integers and floats as an input, and will only return integer and float as an output. And here is a table showing if we add. You can go over this later, because when we try to add two integers together, let me explain this thing too. Float and when you arithmetically operate two floats, the result will always be a float. And if you try to operate a float and a int, the result will always be a float. If you try to operate int and a int, the result will always be a int, unless it is a division. You need not remember this, but remembering this will make it easier to know the type that an expression returns. Is there anyone who didn't understand arithmetic operators and arithmetic expressions? No, right? Yeah. Here in this cell, I am just trying to print the value of 5 plus 2.0 and then the type of 5 plus 2.0 to demonstrate that I made few summary here, right? That float and int will always return float, float and float will always return a float. Here you can see I am operating an integer within float and trying to check the type of that value too. See, you can take your time and go through this later. These are true mostly. Now, relational expressions. Just like its name, they are used to compare whether something is smaller than the other, or when something is greater than the other, or whether something is equal to the other. There are only 5 relational operators: greater than, less than, greater than or equal to, less than or equal to, yeah, okay, not equal to, in, not, is, not, yes. So, these also fall into membership operators too, the in and not in. I think you must have understood the in, right? For now, ignore this and only remember the top greater than, less than, greater than or equal to, less than or equal to, double equal to check whether two objects or two variables hold the same data, and not equal to check whether they hold different data. And I think I have covered is and is not to. Is is the same as double equal to, and is not is the same as not equal to. But here they check whether both of them are the exact same object or not their data. Operands supported by relational operators. Unlike arithmetic operations, which can be used on any numeric data type, float, and complex, relational operators can be performed on different types of Python objects. Here is a list of operations and the type of values that they can be used upon. See here, greater than, less than, greater than or equal to, less than or equal to can only be used on integers, floats, and strings, and date objects. We will learn about this later. Not equal to, double equal to can be used with any data type, and in and not in can only be used when the right side value is an iterable. What did I mean by that? See, ignore this. Just forget in and not in ever existed, and just remember these two. Relational operator hierarchy. Yeah, I will go over this later. Print. Logical operations. This is the easiest part. If you know these are called end table and an OR table, just showing us that if true and true is a true and false is a false, there is no going over it. We have to by heart this. This represents the end logic, and the below table represents the OR logic. And I think not is easy. Not true is just false, right? Not false is just true. Logical operator hierarchy. Yeah, bitwise operators, you can skip this. Assignment operations, we already covered just. There is something called compound assignment. If you are interested, learn this, you will understand this easily, or just skip it. Even this you can ignore now. I just went over arithmetic operations, relational operations, and logical operations very briefly, right? I just explained what symbols are used in arithmetic, what symbols are used in relational, and what symbols are used in logical. Now let me try to write a complex operation. Let's say 1 plus 33 greater than 34. Take a look at this. This doesn't make any sense, right? Here, in a single expression, I have used arithmetic operation between two numbers in here. I have used a relation operation in here. The same with in this part of the expression too. Then I logically operated the result of this and the result of this, right? You might ask, how is this even executed? Whether 33 is compared with 33.43, or will the addition be carried out first and then the result is checked against this value or not? This is what we call operational hierarchy. There is a clear set of rules on when there is a complex expression, which operator should be executed first. There is a clear hierarchy. And I have written the hierarchy clearly in each section. Let's first go over relational expressions, hierarchy. Preliminary conclusions, probability. Yes. The hierarchy of parenthesis is always greater than unary, greater than arithmetic, then greater than bitwise. You can ignore this. This never existed. Then membership, then relational, then logical, then assignment. This is quite a mouthful, but know that if something is written in the parenthesis, you should first calculate that. In this expression, you just know that since these are in parenthesis, I need to calculate this first and calculate this first separately. Now, since you are inside parenthesis, if there is another parenthesis inside here, that must be calculated first. So there is nothing inside this expression. There is no other parenthesis. We will be going to unary. We will be going to unary. Unary is nothing but a single value. Any data type is called unary. And first arithmetic. Here in this expression, there are two types, right? Here, the plus is arithmetic and greater than is relational. Which one? Which one should you run first? Should you do 2 plus 33 or 33 greater than 3343? Here 33 has two different operations being performed on it. And according to our hierarchy table, if an operand or data has two different types of operations being performed on it, we should pick in this order. We are picking that arithmetic is greater than relational. So we should first add 2 with 33 and then that result is operated against 3343. Yeah, you can even check this. Let me print this one separately. Oh. See, 2 plus 33. Okay, let me do something like this. Let me raise it to the power of 33. Yeah. Here the power is also an arithmetic operator, right? True. Why? Because 2 power 33 is way greater than 3343. This is why. And then, since you have calculated this parenthesis part, this expression is complete. And now you can do the same with the next one. Even in here, 3333 has two operations being performed on it. One is multiplication and the other one is relational operator, less than or equal to. Now, according to this hierarchy, the arithmetic operation should be performed first, and then the result is relationally operated with the next operand. Just remember this: when there is a complex expression involving multiple expression types like arithmetic, membership, relational, logical, and assignment, try to remember this hierarchy. We should first calculate whatever is in the parentheses or circle brackets. Then, if an operand has two types of operations being performed on it, perform the arithmetic first, then the membership next, and relational. Yeah, here let me clarify one more thing. What if an operation has both membership and relational in it? Like see, 33 plus 33 greater than 44 in true or false. Here, the number 44 is being operated with two operations, right? Which is this is greater than operation, and here in is membership operation. If you see, I wrapped them in circle brackets and didn't, but here I didn't put them in because membership and relational have the same level. How should I put this? Yeah. Here, 33 has two types of operations being performed on it. One is an arithmetic plus, and the second one is a relational greater than. according to our chart, we need to first perform arithmetic, right? Then the result will look 66 greater than 44. Now the 44 has two types of operations on it: less than, greater than, and in. Here, you won't understand this. Mm, Relational logical assignment. Yeah, do something. Just ignore the brackets and follow the hierarchy itself. If an if a data or a data type has two types of operations being performed on it, check from the left and perform the operation that has the highest priority, and then operate that result with the next operation. Clear? Uh, Is there anyone who didn't understand the hierarchy part? You will face
Like
very.
inside
Yeah,
brackets, two arithmetics came like addition and multiplication like that. So which one will be first to perform?
yeah. Here, uh, addition. See, this is what you are asking, right? 33
Addition and multiplication like same time like within bracket. Both are arithmetic, right? Like then addition will be performed first or like multiplication. Like
exactly. There are two types of hierarchy. This is what I found very difficult to explain. First, you have to check a hierarchy between types, expression types. Arithmetic operations always exceed relational, then conditional, then assignment. Inside arithmetic operation, there is also a hierarchy. And where I must have written it here. See here, plus, minus, and not equal to is greater than, power greater than, multiplication, division, floor division, modulus greater than, unary plus minus, plus minus. I will explain the difference between this plus minus and this plus minus later. But inside, even if an number has two types of arithmetic operations being performed on it, then you have to choose the operation hierarchy based on this flow. This is written in every expression section too. There are two. First, you need to check the hierarchy among arithmetic, relational, assignment, and membership. And then inside the arithmetic, if there is also a hierarchy between operations. The first priority will be given to unary plus and minus. Unary plus and minus is nothing but if I do this is plus 2, right? A is equal to plus 2 minus 33. Here, intuitively, you must have understood that plus 2 is a number. And then I will operate plus 2 minus 33. And you won't do something like this. 2 minus 33 and then plus. These are two different things, right? Unary plus and minus is nothing but the positive and negative positive and negative symbols we put before a number. That is why they are carrying the highest priority. And then the power takes the next priority, and then the multiplication, division, floor division, and modulo. If you see, they are inside the same bracket, meaning that if an number is operated by multiplication and division, it doesn't matter. Both have the same priority level. So which comes first will be executed. Like here, 33 star 44 by 44. See here, multiplication and division take the same priority, same hierarchy. So what we do is just execute the, when we read from left to right, right? We execute the first operation and then perform the second operation. This is nothing but equivalent to this here. Clear? We have to check the hierarchy across expression types. We have to check hierarchy within an expression too. And I have clearly written which which operator has which hierarchy. If I put them in the same bracket, this means that both of them share the same level, and we should execute the first one from the left side. This is clearly written, and there are plenty of examples, so you need not. This might take some time, but just to go through the notes and try to validate and validate every condition. In case of relational operations, there should be a hierarchy. Yeah. See, in case of relational operator, is and is not take the highest priority, then the membership in and not in take the next priority, and then less than, greater than, less than or equal to, greater than or equal to, and then equal to, and double equal to. What this means is, if I do is true in false, this doesn't make any sense. I'm just writing an expression to demonstrate its behavior. Here, age is the data, right? Age has two types of operations being performed on it. Capture this in a variable. Is and in. Is an identity operator, and then in is a membership operator. According to the hierarchy, we must execute the is age first, and then the result with membership operator. Is age is true, right? True in false is false, so the result should be false. Right. Okay. Is age. Invalid syntax. Age is. Yeah. Here this makes sense. Here true has two different operations being performed, is and then in. According to us, is age true, which is true. True in the list containing just a false, which is false. So you get a false. This is quite hard to digest, I know. But here, this notebook is dumping everything. There is no other. I mean, this is the peak of our Python course. After this, there is nothing else you should be afraid of. Expressions are different. Expressions are categorized into arithmetic, relational, logical, and membership and assignment and stuff. There are bitwise operators, but you can ignore them. Learn what data does each expression contain, what they return, and what operators, what symbols each contain, and what hierarchy across expressions, and then across within the same expression too. Yeah, is there anyone who didn't understand this again? I will go over this again. Okay, I am assuming you understood.
ఈజీ వాడే దగ్గర కొంచెం కన్ఫ్యూజ్ అవుతుంది.
ఈజ్ ఇన్ పార్ట్ దగ్గర కొంచెం అర్థం కాలేదు. ఇది దిస్ థింగ్ రైట్. ఈజ్ ఈజ్ అన్ వెయిట్. ఇది మీకే కాదు, చాలా మందికి అర్థం కాదు. వాడే వాళ్ళకి కూడా మేము అప్పుడప్పుడు మర్చిపోతా ఉంటాం. ఈజ్ ఇన్, నాట్ ఈజ్, ఇవి. లెట్ మీ గో. ఓకే, ఇక్కడ సెక్షన్ ఇది. అసైన్మెంట్, నాట్ అసైన్మెంట్, ఈజ్ రిలేషనల్. Yes. First, we need to understand one thing first. Is a relational operator. This is clear, right? And in is also a relational operator. In is a membership operator, but it also falls into relational. This is why I have listed them down in my relational expressions and operators section. Here, the problem is that the value true is being operated by both is and both in, right? Now you have a dilemma. Which one should I execute first? Should I execute age is true first, or should I execute true is true in? This is quite hard to understand, right? 1, 2, 4. Let me write down various versions of this. This is the actual expression, and you have a dilemma. Which one should I do? Age is true first, or should I do true in 1, 2, 3 first? ఇది అర్థమైందా మీకు?
Yeah.
Yeah, this is clear, right? And now when you know which one to, let's say దీనిలో ఏదో మీకు తెలియదు, ఇది ట్రూవా తెలియదు, కానీ దీన్ని చూస్తే భయం వేస్తుంది, కానీ దీన్ని చూస్తే వేయదు. ఎందుకు మీకు తెలుసు, ఏజ్ ఇస్ ట్రూ అంటే సంథింగ్ రిజల్ట్ వస్తుంది. దట్ రిజల్ట్ ఈజ్ ఇన్ దిస్ లిస్ట్ అని చెక్ చేస్తున్నాం. హియర్ ఏజ్ ఈస్ ఇదో రిజల్ట్ వస్తుంది, ట్రూ ఇన్ సంథింగ్ ఒక రిజల్ట్ వస్తుంది. ఏజ్ ఈజ్ దిస్ రిజల్టా కాదా అని చెక్ చేస్తున్నాం. క్లియర్ కదా? అంటే ఇది డైరెక్ట్ గా అదే పెరాంథసిస్ లేకుండా మీకు ప్రొడక్షన్ కోడ్ లో కనిపించవు. ఇట్లా రాయం, ఇది బ్యాడ్ కోడ్ అనమాట. అంటే థౌజండ్స్ ఆఫ్ లైన్ కోడ్ రాసేటప్పుడు ఆటోమేటిక్ ఏం జరుగుతుంది అంటే మేము కూడా మర్చిపోతా ఉంటాం. ఈజ్ ట్రూలో ఈజీ ఆపరేటర్ కదా, ఇది ఇన్ ఒక ఆపరేటర్ కదా, వీటి రెండిట్లా హైరార్కీ ఏంటి అని. అప్పుడు మేము కూడా చేసేది ఫస్ట్ ఏంటి అంటే గూగుల్ సెర్చ్ చేయడం కానీ డాక్స్ రిఫర్ చేయడం కానీ. దీని కన్ఫ్యూజన్ అవాయిడ్ చేయడానికే మేము మరి రిచ్ కోడ్ రాస్తున్నప్పుడు ఇట్లా పెరాన్సిస్ పెడతాం అనమాట. వన్స్ ది పెరాన్సిస్ ఆర్ ఇన్ ప్లేస్ దేర్ ఇస్ నో డౌట్, రైట్?
ఇప్పుడు ఈ కండిషన్ ట్రూ రిజల్ట్ లో ట్రూ రావాలంటే ఇన్సైడ్ బ్రాకెట్స్ మనం ట్రూ పెట్టాలా?
రిజల్ట్ లో ట్రూ రావాలంటేనా?
ఒక ఎగ్జాంపుల్ అంటే ట్రూ
ముందు రన్ చేద్దాం. సి ఫాల్స్ అండ్ ఫాల్స్, ఎవ్రీథింగ్ ఫాల్స్. ముందు ఇది యాక్చువల్ ఎక్స్ప్రెషన్, దాని ఈక్వివాలెంట్ ఏదో ట్రై చేద్దాం, ఏదో కనుక్కుందాం. అకార్డింగ్ టు మన హైరార్కీ ఈజ్ ముందా ఇన్ ముందా? సి ఈజే ముందంట, అంటే దిస్ ఈస్ ది కరెక్ట్ వన్, దిస్ ఈస్ ది రాంగ్ ఎక్స్ప్రెషన్. అంటే రిజల్ట్ ఒకటే ఇచ్చిందిలేండి, కానీ దీనికి అర్థం ఇది కాదు. ఇది ఓకే కదా?
ఓకే.
రిజల్ట్ ఇగ్నోర్ చేయండి. దీని మీనింగ్ అసలు మీకు ప్రాబ్లం వచ్చింది. ట్రూ మీద ఈజ్ ఉంది, ఇన్ ఉంది, ఏది ముందు చేయాలి? అదే కదా. మీరేం చేశారు, దీనికి ఈ రెండు అవ్వచ్చు, ఇది అవ్వచ్చు లేకపోతే ఇది అవ్వచ్చు. మీరు హైరార్కీ టేబుల్ చూసి ఈజ్ గ్రేటర్ దాన్ మెంబర్షిప్ ఇన్ అని అర్థమైంది. సో ముందు ఈజే కంప్యూట్ చేయాలి. సో ఇట్లా ఇదే పెట్టాలి అని ఒక ఆప్షన్ ఎలిమినేట్ చేసేసారు, ఈ ఆప్షన్కి వచ్చారు. ఇప్పుడు మీరే అడుగుతుంది ట్రూ ఎప్పుడు వస్తుంది అని అడుగుతున్నారు, అంతేనా?
అంతే.
యా, ఈ రిజల్ట్ ట్రూ ఎప్పుడు వచ్చింది? క్లియర్, రైట్? సింపుల్. ఏజ్ ఈజ్ ట్రూ అనే దానికి వాల్యూ ఏంటి? రిజల్ట్ ఏమొస్తుంది? ఏజ్ ఈజ్ ట్రూ. ఇది కొంచెం ఇబ్బందిగా ఉంది డైజెస్ట్ చేసుకోవడానికి. ఈజ్ అంటే నథింగ్ బట్ డబుల్ ఈక్వల్ టు అనుకోండి కాసేపు.
ట్రూ వస్తుంది, ఆ ట్రూ ఇన్సైడ్ బ్రాకెట్స్ ఉంటే మళ్ళీ ట్రూ వస్తుంది, అంతే.
అవును కదా, అంటే ఇది లిస్ట్ అనమాట, బ్రాకెట్స్ కాదు, లిస్ట్ డైరెక్ట్ గా రాశాను. ఈ అది గనక ఉండుంటే ట్రూ వచ్చి ఉండేది. అంటే మెంబర్షిప్ అదే కదా ఎత్తుతుంది, ఒకటి ఇంకో దానిలో ఉందా లేదా అని ఎత్తుతుంది. సి ఏజ్ పైన మన వాల్యూ, ఓకే ఏజ్ ట్రూవే కదా, ట్రూ ఈజ్ ట్రూ అని ఎతికాం, ట్రూ అని ఆన్సర్ వచ్చింది. ట్రూ దీని లోపల ఉందా అని ఎతికాం, ఉంది అని చెప్పింది. ఒకవేళ లేదనుకోండి ఫాల్స్ అని వచ్చేది. Expressions, when we are dealing with expression, what we should keep in mind is, since you are starting out, you need to by heart every form of expression and the hierarchy of across expressions and within the same expression type too. But you will get used to it. It will see ఇవి ట్రిక్కీ క్వశ్చన్స్ అనమాట. ఇవి ఎట్లా అంటే అప్పుడప్పుడు MCQs లో అడుగుతూ ఉంటారు. రియల్ లైఫ్ లో మనం ఇట్లాంటి కోడ్ నేను రాయను, ఎవరు రాసిన ఎంకరేజ్ చేయను. ఎందుకంటే ఫ్రమ్ టైమ్ టు టైమ్ వి ఫర్గెట్ స్టఫ్ అన్నమాట. ఇది మీకే కాదు, నేనే రాసిన, నేను వారం తర్వాత చూస్తే ఏంటిది ఎట్లా రాశాను, దీనికి వాల్యూ ఏంటి అని నేనే కన్ఫ్యూజ్ అవుతూ ఉంటాను. మీరు బిగినర్స్ కాబట్టి మీకు ఇట్లాంటిది ఒకటి ఉంటది, హైరార్కీ ఉంటది, ఎక్స్ప్రెషన్ కి హైరార్కీ ఉంటది. దీని లోపల కూడా సబ్ హైరార్కీలు ఉంటాయి, మనం నేర్చుకోవాలి. ఇప్పుడు మీరు ఇప్పుడే ఇగ్నోర్ చేసేసారు అనుకోండి, తర్వాత మీకు తెలియదు. అందుకని ఇవన్నీ ఇంత డీటెయిల్ గా చెప్పాల్సి వస్తుంది. Final conclusion: arithmetic operations mostly on number will return back a number, integer or float. Relational operators, mixed data types, and will always return a Boolean value, true or false. Conditional operators are not. There are only three conditional operators: and, or, not. You need to by heart the table. What true and they will only take Booleans as input and return back Boolean as an output. Together, in the later parts of this course, we will be using this expression to accept data from the user, to calculate, derive new values, and then make decisions based on the data. మీకు ఇప్పటికి you might have an inkling about right now. When you saw true and false and relational operation and relation and conditional operations, they are generally used to make decisions, right? What if John is under 18 years of age, so I cannot admit him into my college, something like that. We can model that like this: John age is equal to, let's say we are building an student admission platform, and there is a condition. When I want to write a condition, what I will do is, if John age greater than 18, print don't enroll. See, here you can ignore what if is doing. Just know that John age is a variable storing the data, right? And John age greater than 18 is the actual heavy lifting. This is telling me whether the John age is greater than 18 or not. And then I am making decisions based on this return value, which is a Boolean. If true, do something. If false, do something else. Something like that. Clear. Now, yeah. Tomorrow, we will go over conditional statements. Here you have seen if, right? What does if do? We will learn that. And then later, we will learn about strings, lists, tuples, and so on. Yeah.